you know,
Yeah.
Friday?
We're having
Next Friday.
Next Friday we have our unit test.
Yes, which is kind of nice because then we won't have any homework over break.
So what if I just don't show up Friday?
Then you'll have to take it when you get back.
Okay.
All right, so let's talk about this. And the warm-up was kind of to get you to see what happens. But let's talk about this real quick. So I want to make a table. And in my opinion, if you have no idea what an equation does, you can make a table and kind of just plot points and kind of figure out generally what's happening. So far, we have looked at mostly linear equations. So a recap of what we've done, y equals, 3x plus 7. We've done that. We should know that we start at 7, we go up 3 over 1, and it's a line. Okay? What makes this not a line? Yeah. Yes, exponents. The variable is in the exponent. What do you think we call these type of functions when the variable's in the exponent? Exponential. These are exponential functions. Okay? So let's talk about what happens. So what value do you think I should put first on here? 1. I like it. So 1. If I put 2 to the first or 2 to the 1, what does that equal? Yeah. Yep. Just 2, right? So if I plug in 1 here, I'm going to get just 2. What's another value we should consider? Yeah. I agree. 2 to the 0 equals 1. Anything to the 0 power. Okay. So I'm going to go over here and I'm going to go ahead and make a graph. And I'm going to plot these points. So I have 0, 1. I've got 1, 2. Okay, so far. And then let's talk about what's going to happen to this thing. What is 2 going to give me? So then 2 to the second power is 4. Okay. And then and then 3 is 8, right? And then the next one, 4 is 16. And then I think I need more table. So I'm going to add another table here. Hopefully you have room. So then 5 is 32. So what is this number doing? It's doubling. Okay. And then 6 is 64. 7 is 128. Have you ever heard the term that it's growing exponentially? What does that mean? Something. It's not rise over run for sure. If I say, yeah. Go ahead. Yeah. Great.
It's starting to go like this.
Yeah.
It's starting to go up really fast.
Really fast. It grows really fast. Okay. Linear always grew at the same rate. Exponential, it's like a rocket. So what happens here, and I'm not going to put values here, but what happens is it's going to go like this, and then it shoots up. It almost gets straight up and down. It doesn't, because if it was straight up and down, it wouldn't pass a function test, right? But when I start putting large numbers in here, it just shoots up. Okay. What do you think happens on the other side? Okay, that would be a good guess that it shoots down, but let's talk about it now. So I'm going to make a table down here. Okay, yeah.
It would go straight, like it would shoot straight forward.
Straight? What are you talking about? Okay, so let's play with it, and you can keep thinking about it. You need a writing pencil? I got a colored pencil here. I don't know where that came from. But.
It would like go down a little bit.
Okay, so let's talk about this. So we got 0. What is -1 going to give us? Yeah.
0.5.
Or can we do it as a fraction?
Or 1/2.
1/2, right? So it's going to be 1 over 2, right? Because if I plug -1 in there, that just means the 2's in the wrong spot. The 2 goes downstairs. What is -2 going to be?
1/4.
1/4. -3 would be 1/8. Okay. So, someone who has a calculator handy, what does -10 give us?
One over 1,000.
Give it to me as a decimal. That's fine.
1 over 1,000.
No, it's a decimal.
0.0007.
Okay. So 0.9. What is this number? It keeps going. Now here's something that was a mistake a lot of people make. We're talking about 2, and I'm going to make this a negative power, and I'm just going to keep getting bigger and bigger. Some people wanted to say that this equaled -2. Exponents cannot make things negative. Okay? Exponents just mean move it downstairs. So this is not a negative. This just means moves downstairs. So what we end up with, if this is getting really, really big, then that means we're moving the number down below. And this number, now we have 2 to the really big down here over 1. What is 1 over a large number? A small, define small number.
Something that's not over 1.
Something that's not negative, but it's still positive.
Yes, a really small positive. Can this ever become negative? No. No matter what number I plug in here for the exponent, this will never become negative. But it gets super close to what? 0. Did you ever played the game where your mom and dad are like, hey, don't touch your brother? Exactly. And how close do you get? As close as you can. That's what this line does. I'm telling this line, don't touch 0. And it's like, I'm not touching 0, right? And then your brother's like, you just touched me, let's go. Right? Right. Okay. So what this does is this gets super close to 0, but it never touches it. If I zoom in on this, way zoom in, there should be a little bit of a hair, right, between 0 and that line. Okay. It approaches that line but never touches it. This is my brother that I'm like, I'm super close, I'm not touching. Okay. So, characteristics of this graph. I kind of broke here, so I'm going to write this answer over here. Tell me things that this graph is doing. Yeah. It's going up. So, can I say positives up fast? Okay? Because it's definitely not going up on the other side.
Hey, could you just say positive?
Yeah, but we don't use that word anymore. We only use slope for lines. But, okay, negative. What is negative side doing?
It's going like slower. It's going like
Close to 0. There's one other thing that's not obvious, but I want to talk about the intercept. Y-intercept is what? 1. Okay. And I'll tell you that comes from what, and this is weird, but what number is in front of the 2? What number is in front of the 2? Yeah. 1. There's like a 1 there, and we'll talk more about that in a little bit. Okay?
Wait, I have a quick question. For these, if the exponent or like it's negative, you still have to make like maybe go below the you still have to do like the same way we were doing it, right?
Yeah.
Like so it would be like if there was like for the other questions, let's say it was like 3 times 3 times 2, like, to the negative second power. You have to take that negative 2 and make it go down, right?
Yeah, it makes it a fraction, 1/9.
It's a fraction.
Yep.
Yeah, just make sure we said to do that.
And we can consider it as a fraction, we can consider it decimal, but the kind of the point we need to know is that as the negative number gets smaller, meaning more negative, so as this grows, so like 3 to the negative 100, that's going to be super close to what? 0. So it gives me that, you know what this is? This is scientific notation, something we'll learn at the end of the year. So this is saying that there should be 48 zeros and then the 1. So this is 0.00000. I got to say that 48 times and then 19.
Oh, I thought you were gonna say.
Yeah. Okay. So super small. All right. Anyone want to guess how to pronounce this word? Yeah. That's exactly right. No, I'm kidding. No. Say again. Okay. Close. Yeah.
Asymptote.
Cheater. So we say this part, and then this part, and then we say this part. So what's that first part? Say it again. As. M.
I counted
So-
48 zeros and take
so
the
you-
Why did you do that?
Huh?
Why'd you do
I know it's weird. So it's ass,
What?
M, tote.
Shut up.
Say it with me. Ass,
I'm
M,
not saying that word. It's against
tote. If you're in the hallway and you're like, you might want to add M tote to the end of it and you won't get in trouble. I don't think. I don't know. But it's ass, M tote. Huh? Yeah. That what? I taught you asymptote? Okay. And that P kind of disappears a little bit, but so it's ass, M tote. Okay. What is an asymptote? So we had an asymptote over here. Okay. It is the dotted line that we don't touch. So in that last graph, we get super close to it. It's our brother that we're not allowed to touch, but we get as close as we possibly can. That's what the asymptote is. I'm sorry? Do what? No. Well,
He does.
to me?
Does he have a brother?
Oh, to my daughter?
Yeah.
They don't do that. I don't know. I mean, we did it with my brothers and I did it when we were younger.
I do it like to my sister. I don't really. She'll just like get mad at me. I'll do it.
Yeah. Okay. So, I'm going to skip this for now. We'll come back to it. So let's talk about this next one. So we're supposed to be able to kind of identify what this graph is doing when we first look at it. But right now we're still kind of discovering how to figure that out. So I'm going to make a table. Okay. What do you think the first number I want to put down here is? 0. I like 0 on here. Okay. So 0 is going to make this equal to what? Makes the 4 to the 0 1. It would be 3, right? Because I go, it's 3 times 4 raised to the 0. That 0 only grabs that 4. So it's 3. Okay. What other number do you think I want on my table? 1. So if I plug in a 1 here, it gives me 12. And then really what I want to know, and then 2 is going to be, what is this going up by? What is the difference here?
9.
And not the difference, but what multiplication is there? 4. So 4 times 12 is 48. And then we kind of should know that as this goes up, Okay, so as this goes up, what is this number going to be? It's not down. It's going to be really, really big, right? So this is going to be big. It's going to rise very fast, exponentially. And then we need to talk about what's happening in negatives. -1. Let's go ahead and do decimal. Can you do that? Anyone do that in their head?
Wait, what did you say?
-1.
Oh, then it goes. Then it would be
1/3.
Nope.
no, it's a 1/9. It's
1/12.
0.3333.
1/12.
I would.
1/12.
Wait, that's 1/3.
Yeah.
Is it 3/4?
If I make this negative, that means the 4 goes where?
1/12.
Down. It's just 3/4.
Oh, I got it right.
Who drew that?
Sorry.
I don't know.
She did not listen to what you just
Yes,
said.
I did.
I just more people get it wrong.
-2.
just saw it.
What would that be?
8, 6/8.
3/8.
What are you times by 4? So it would be.
What?
It would be
12/16.
3/32.
It's 3 or 12.
It's
I heard-
3/8.
3/16.
Can you just multiply?
No.
Multiply the 4 by 4.
And if I go really big here or really negative, I don't know, does that notation make sense? A negative larger number, so large negative, what is this going to go to?
16 kajillion.
Oh, okay.
What's this? What is the asymptote here? Yeah, but it never gets below what?
Over 0.
It-
never gets below 0.
Good. So it approaches 0, as we would say.
Is 0
Okay.
positive or negative?
It gets close to 0 on which side? That's a great question.
No, I'm saying is 0 positive.
It's neither. But as we approach 0, is it going to be on the positive or the negative side?
Wait, how did you get
Yeah, that's the Young Sheldon's.
That's the young.
3/16. That's what that is.
Hey, I've got a question.
thought you said it was 6.
What's like the biggest number you can like? What's the biggest fraction you can go to?
All right, let's keep going here.
There's not a physical representation.
So we don't need any negative values here because this does not go negative. It starts at 3 is my intercept, my y-intercept. And then at 1, it's going to go up to 12, which is kind of off my chart. And then on the left side, -1 is going to be about here.
Oh, we don't do it.
We have a negative x, but we don't have, it doesn't go below the y-axis. And then it gets small. So it's going to be like this. It's going to go up. It'll be like that. So we want to talk about what this graph, how is this graph kind of different or what's going on? So first, when we get real big positive, what does it do? It goes up fast, right? So it does the same thing as the last one. And when I go negative, it does what? Goes down, gets it close to what? Close to 0. My y-intercept this time is what? 3. Where did that y-intercept come from? Where did the 3 come from?
The time.
The table.
Right? When x is 0.
It was 3.
But if I look at this equation, I can very quickly say my y-intercept is going to be what? 3. Why?
Because it exits out to 1.
Yeah? Okay. You're kind of all answering it, but you're not,
Because the 3 symbolizes the x value.
because this number right here, okay?
What?
Because that number in front there. So my function y equals 3. That's where this 3 comes from. Okay, so that 3 is whatever that number is there. The last thing I need to say is where's my asymptote? So I have an asymptote at what? So this approaches what but never hits it? 0. this, how do I name this line? If I were to graph that, what graph would that be? How do I graph that line? You're right, it's 0, but what's 0? So it's x equals 0. Is this line, right? So that's my asymptote at x equals 0.
Is that how it's gonna be for everyone?
Yep. Well, yeah, for now, I think. Yes. So let's go to the next page. So now we can kind of, talk about what these different parts are. What is that A?
It's the axis.
Where was it on the other side?
That's y-intercept.
It's my y-intercept. What is my B?
I'm not on the right page. Your x-intercept.
It's more like slope, but we don't use that word.
It's,
It's
what it increases by.
Okay. What operation are we using?
I don't
Multiplication. So this is our change.
change multiplication.
Oh my gosh, I spelled that wrong.
Y.
And it's multiplication, right? This is, and I gave myself a little cheat sheet so I wouldn't forget. This is called my constant. And then this one is my ration. Okay? It's like my multiplication.
Why do you use
What are you spending? I don't know. I just like the way they work better.
Would be like
Here, let me help you.
not be able to fix mistakes.
Andy also doesn't have.
Yeah, because my students eat all my
I
pencils.
am. Shady. Shady.
Actually says.
Shoot.
Chill. That's chill.
Chop. Chop. Shade.
And it's multiplication. So now we're being asked, we've been asked, here's the equation, can you graph it or can you make a table? Now I'm given the table, can I write the equation? These are not that challenging because there's only 2 parts, which is kind of nice. I got to figure out what is this change here. If it goes up by 1 here, what is it multiplying by? 3. And you'll notice that each time it jumps by 3 here. Okay. It's 3. It's being multiplied by 3 as we go up, right? Where is it starting? What's our constant? 4. So this is 4, parenthesis, 3 to the x. Okay. Now we've only seen, and if I were to draw this graph, they've all kind of done the same thing where they go like this, right? Now look at this next graph. Let's just go with what we know and see what's going on. Okay. So my function here, this time, why am I not going to use f of x on this one? Why am I going to use the letter y?
Because it goes past it, it's 0, right?
Okay. So I'm talking about notation. Why did I use f of x on this answer, but over here I'm going to use the letter y?
That was the same thing.
It's a graph.
Because over here, they told me f of x. Over here, they're telling me y. They're defining the notation. We need to know 2 numbers. We need to know what's the start, what's the y-intercept, and we need to know what are we multiplying to get the next value. So let's go one piece at a time. Where are we starting on this one? 128. And what are we multiplying each time to get the next number? Close.
Negative
1/2.
Is 1/2 the same as negative 2?
No. But so you're asking me -2, 1/2, and what does she mean when she says is -2 by 1/2? These are not the same, but how can I write 2 and it be written? What do I need to add to this 2? Yeah. Okay. But I think what she's getting at is that those are the same, right? It's not a negative number, it's a negative exponent. Okay. So when I multiply by a fraction that's less than 1, what does my graph do? It actually goes down. Okay. It goes down. And then this way, it's going to skyrocket up the opposite way, and it's going to approach 0 this way. Okay. Let's try this next one. So the same thing. They don't tell us what notation to use, so I don't know. I think we like 0, or I mean y equals. Someone have an idea? How about someone on this side of the room? North side.
Y'all like never answer that.
Well, someone on this side.
Yeah.
You got it? They got it. They got it. Patience. Anybody?
Breathe in.
Yeah.
Come on, when do you smart people
Uh-huh.
about?
3,
Okay,
and then 4.
and I think you have to raise your hand every time.
Just like that?
Yeah, that's great.
What do I need to add to this? I totally get what you're saying, and you almost got it. Parentheses where? Around the 4. I could either put parentheses around the 4, or I could put a multiplication symbol here. Means the same thing. And then what else do I need? Which is on the 4. Good job, Eli. How did we do that?
Yeah, I'm confused.
We need to know where we start,
Yeah.
and then we need to know what number is this changing by.
Oh. Okay. Got it.
Yeah.
I have a question about the next one.
Yep.
How is there 3 and 1?
3 and 1.
Or like not 3 and 1. I'm saying like there's 3 numbers in one parentheses.
No, that's a column.
Oh yeah, that's a 0, 2,187.
Oh.
Yeah. Someone have this equation. Yeah. Go for it.
Y equals 2,187. Parentheses. Parentheses, I don't know. To the power of X.
Okay. Someone have
Isn't
the.
it negative?
It's not negative.
It's a fraction.
It's a fraction. Yeah, you got it. Okay. 1/4, close.
1/5.
So the question is, what am I doing to go from here to here? I think it's hard to do it there, but what is that? So 81 times what? And I heard it, 1/3.
It's so close.
Now, honestly, the way I would have approached this is I would have gone 81, and I would have said divided by 3 gives me that 27. It's not 3, it's 1/3, right? But 81 times 3 to the -1 is what? Yeah. Okay. Okay, so let's go back to this word problem, because we will have word problems on our Sabas. And I think that these are kind of interesting. Exponential word problems are very interesting. In our district, in this school district, right? And actually, a friend of mine who's a teacher, just told me that somehow there was a virus that got on one computer in the school, and then that computer passed it on, and then exponentially is what happens. So you put it on one computer, and that computer affects 5 other computers.
What virus is on the computer?
Okay, now I don't know. Now I got to point out that how many computers are affected after 1 hour? How many computers are there on the left? 6. You're like, 6, not a big deal. But this is here's the problem. Then these 5
Get 5 more.
get 5 more.
Oh, yeah,
That's like mine.
31.
Okay.
30.
And it grows dramatically. And then the next hour, how many are going to be affected?
everyone.
It does not take long for everybody, right? If this is an hour,
125
and it-
people. Plus the rest.
yeah. So if
There's a lot better examples.
okay, let me get through this. If you keep going, right, and say this bug is working at night and everyone's at home, by the time we get back to school in the morning, everybody has it, right? Every computer in the district that's connected has it. This happened to a school district, and they're like, we have to shut down our internet. We have to shut down our computers. We're not gonna have computers or internet for like the next 9
Oh,
weeks.
they did it in school.
Right. So now they have to, and let me just tell you, this school district, how do we do attendance?
We
Online.
just didn't have to.
How do we do tests in here?
Online.
Online. How about your other classes? Any tests online? iReady would be gone.
Yes.
Think of all the things that would go bye-bye.
Wait. So if someone in this class or someone in this school got a bug on their Chromebook, then no one would be able to do any work for 2 years.
I mean, it could happen.
Wait, really? How do you get a bug?
You want to get a bug?
No, just like
Would
just
everything
like
be on curiosity?
yeah.
So I will tell you, like, if a teacher's like, hey, I found this software I want to put on my computer, the district's like, no. Why? Because they're terrified of this, right? They know that if there's a bug on something, how quickly it could just destroy the whole system. And I see some of you smiling and there are people out there, hackers, right, who think it's fun to just put a bug somewhere and just destroy a company, right? So, and I actually see why you would think that would be fun, right? To kind of be like, wow, I can create this thing
I can destroy everyone.
and I can destroy all this stuff. Okay.
We have a quick question. So if they just have 1,000 computers that got have this bug, how they figure out how to like get the bug off these 1,000 computers? Do they just why don't they just power wash every computer?
And so what they do all kinds of things, right? You can't save stuff they love Chromebooks because you can't save anything to them, right? You can save a little bit, but you can't save a lot of stuff, right? They love that we use Google for a lot of stuff because where does all of our saved stuff live?
History.
No, it's online. It's not here. It's Google. It's Google's problem. If Google gets a bug, they're gonna know right away, right? And because they're constantly monitoring that. Whereas my computer, I've got such a little amount of stuff saved here because it all saves to Google. So that's why the district loves Google. It's save it over there. You guys take care of that.
Wait, what district was
Anyone know Isaac Miller? His mother was telling me about it. Do you guys know him? He's a 7th grader here. His mom teaches there. I think it was Groveport.
Oh, okay.
So, all right. So let's talk about this problem. A network administrator uses this function to model. Okay, they know how quickly. Also, here's another thing I want to point out. If this wasn't computers, what if these were people? Okay, if these were people and we're talking about a literal virus like COVID,
Or like Amazon.
and we knew how quickly it could spread, right? And here's the thing about COVID. COVID didn't kill everyone it affected, but it killed a lot of people that it affected, right? So I don't know about you, and you don't have to admit it, but I've gotten COVID, right? And a lot of us have gotten COVID after I had the shot to protect me a little bit. I'm sorry?
Did you have to get it since you were a teacher?
No, I don't think so.
Oh.
Okay. But
You just decided.
I wanted to protect myself. But this is why people were terrified about COVID because they saw, here's the thing, this number 5 means that it affects 5 more. If this number is 2, then that means it affects less people, right?
Was ours like 100?
The question, the 2 parts is actually it was around 2, but they realized in this situation, right? If I affect one person, or actually I would affect 2 people, and then they affect 2 people, how quickly would it spread to the whole room?
Like,
Right? And then you go home and you affect 2 people, and they travel to another city, and they affect. This is what COVID did, right? Is it just started spreading like that? And there is a number for viruses. They'll say that the spread number 5 would be crazy big. They get really nervous if it gets close to 2. They want it to be like 1. Okay. So they shut things down when that number gets too high to 2. Okay. So we got to answer this question. It spreads this. X is ours. When will we get to 1,000? How would you want to approach this?
drawing it out.
Okay.
Or you would do like the, I forget what it's called, like the square root.
Okay. Well, I mean, do we want a graph or a table?
Oh.
I personally would want a table. You could draw a graph. You could draw a table. It doesn't matter. I'm just going to go ahead and make a table. Okay. So we know that at the start of time, how many were affected? No, 1, right? Because 5 to the 0 is 1. I love how mean this guy looks. And then at 1 hour, no, 5, right? And that comes from this number.
We affect 1 person, 5 people.
Okay. And then after 2 hours, it's, what are we multiplying by? 5. So what is 25? And at 3,
And then 25, 125.
125. And I don't know about you, but I now want to kind of use my calculator. We're going 5 raised to, anyone want to guess when it hits 1,000?
Right after this,
100.
100.
I would be.
This means that this is 7 with 69 zeros.
That's like
Way too big.
7 quadrillion.
How about 10? Remember, this stuff grows super
That
fast.
would be 7.
After 10 hours,
That's 900.
we're trying to figure out when does it hit 1,000. So more or less hours. 5 to the
It's gonna be like 3.
7.
Time at 4.
5 to the,
What's the 5?
okay.
Huh? 4.5.
So, yeah, you want to do that? 5 to the 4.5.
Why?
Wait, what are we trying to get to?
1,000.
2. 4.25.
Is this how we're supposed to do
4.3.
it?
4.3.
How have we not tried 4.3?
Because Hannah's good.
Oh, I went too
No,
big.
just 4.7.
4.3.
Brother.
That's pretty close.
It's gonna be
4.4.
4.269.
Yeah,
4.28.
4.269.
4.29.
Yeah,
299.
269.
Oh my god. It's not no easy way to do it.
Someone tell me the easier way to do this.
296.
Round.
It would be square root.
No? I mean-
Wait, square root.
We want to know when 5 to the x equals what? 1,000. So here's a trick. I'm going to make the left side my y1, and I'm going to make my right side my y2. What am I talking about?
I have no idea.
Let me rewrite it this way. Y equals 5x and y equals, tell me the other one. 1,000. What did I just write? Starts with an S. We just wrote a system. I just wrote a system. How do I find the solution of this system? Throw it into Desmos. If I go to Desmos, and we want the graphing calculator, and I type in y equals 5 to the x, and y equals 1,000. Okay, I got to zoom way out. I showed someone this the other day, right? I'm zooming, and my graph gets really ugly. I can go over here to my wrench, and I can say that I want my x to be regular numbers. I don't know, like -10 or -10 to +10, because we're talking about time here, right? And I want this number to be from, say, -10 to 1,500.
Isn't that like completely changing the
Okay, say again.
Isn't that like just completely changing the model?
This stuff, I just changed the window. I changed to what I can see. When I zoom out, it just zooms out every part. But what I just did there is I said, I want my X, these are my hours, right? So I want my hours to be this. I know it changes very quickly, but I need this scale to not go up by ones. I need this scale to go up by 200s. So then I go over here, and it tells me that it was 4.292. Okay. Word problems, word answer. If your boss came to you and said, how long is this going to take? And your answer is 4.292.
You'd yell at me.
Okay, he would yell at you.
You'd say,
Would it
"Get out of my
be 4
office,
and
fire."
4 hours and 200?
In 20 minutes.
Let's go ahead and call it hours. So how many hours would you round this to?
4 hours and 20 minutes.
You might say about 4 hours. Ooh, it's getting mad in there, isn't it? Yeah, will you turn it off?
I saw this thing.
There's a switch on the right.
I saw this thing you can get on your Chromebook. Where if you don't want to work, you can like click this thing, and it'll act as your Chromebook is like
Oh, yeah.
setting.
Yeah.
It screwed up because I kept on hitting the word.
So it will take about 4.3 hours. That's how I think I would answer this question. Okay, so your boss would know, okay, we have a little longer than 4 hours, but we don't have 5 hours. Okay? How long do you think it would take to get to 50,000? You feel like it would take a long time, but if I come back here and I change this to 50,000, okay, and then I got to zoom way out. Again, I could fix my wrench here and say I want to go all the way up to 50. Good. Oh, yeah, 0 there. There's my 50,000. It would only take about 6.8 hours. Okay. So that's why the viruses terrify companies, right? Because how quickly it could just mess everything up.
That's crazy.
There is Savas, which will be due Sunday, and then we have this group quiz, which will be due.
Like things.
Yep.
It's like a whistle.
Yeah, it doesn't work very well, but yep.